So this time we're going to do metatables and metamethods, and probably just meta method because we're only going to do one. But basically, I've set up a little Lua script here that doesn't work yet. We've not implemented anything here, but the idea of this is I want to be able to call this function called createVector, and it's going to make a table for me. This vector is just going to have an x and y component in it. I'm going to make two of those. I'm going to set the x component on these two different vectors, and I want to be able to add them. So it's quite simple, really, and all it is I want this program to do exactly what it does there. Add these two vectors together. So I've created a little Lua program here, and I've executed it, and I've just added a little bit of extra thing that I've not really been checking error codes in the other tutorials, so this time I am just going to check that the Lua do string worked okay, and if it isn't, I'm just going to print the error out. But apart from that, that's just a really simple Lua program that's just inlined straight here in the file, and I can execute that now, and we should get our error code, I think. Well, we would do if it built. I'm missing a brace somewhere. Where is it? There we go. So attempt to call nil value create vector. There we go. That's what we expected because we haven't made our vector yet. So what a metatable is basically in Lua it's just a normal table. It's not really anything special on its own. It's just a table that's used in a special way. So it's no different to the tables we made last time. But it's just you do something special with it, and you kind of store it somewhere special. So it's nothing magical in that respect. Like I said, Lua only has its 8 types or whatever, so a metatable is just a table, and it's one of those types. But what it does do is there's a few special like fields you can put in this table in Lua, and you can attach this this metatable onto another table or onto a user datum, and it can change the way that behaves. So you can make it so that if you call to look at something in that table that doesn't exist, one of our meta methods will get invoked, and then we can make that meta method do anything that we want to. So we can make it return a value, or we can make it assert, or we can do whatever we need to do. So it's just a way of us changing the way that a table or a user datum behaves, and it's really quite useful, and it's what kind of starts to make Lua quite powerful, even though it's just getting away with using things that it had before, which is just using the table. So the first thing we need to do is we probably need to create this function. So I'm going to create this function in native code. I'm going to do it slightly differently to the way I did it before. I'm just going to create a struct here. Again, what I'm going to do is bind a native function to Lua, but because I'm doing it right here inside my main method, and I'm trying to put everything in one place, I'm just doing it like what I've got to do here is put this inside a struct, and then I'm going to make a static method in here, which is one of Lua, the function that Lua expects us to call. So let's call it createVector. Let's call it createVector2D just to show that it doesn't have to be the same name as what we call it in Lua. We've got the Lua state. So that's the function signature that Lua expects all of our native functions to be called. And again, I'm going to return one value from this because I haven't written the function yet, but this will have to return our table that we want to make. So let's bind that to Lua to start with. Let's bind this native function. So all I've really done there is just created a struct and then made a static method inside. Again, it's kind of syntactically similar to the way I did it in the previous ones with the lambda, except the lambda does have a slight drawback in that I can't call one of these functions from another one. So if you do want to do that, which I'm probably going to do in this tutorial, then you might want to change it. But essentially, again, it's the same thing. We just need a function with that signature, and that's what we've got to bind to Lua. So I'm going to bind that one in down here. So to bind functions, we do push C function, and we give it a name. And in this case, it's a static function of this vec I've just created. So there we go. And then I'm going to set a global now. Set a global. So remember, this global, it wants the last thing that I pushed on the stack, which is my C function. And in here, I've called it create vector, so I'll call it create vector there. So sometimes it's a bit confusing when you see the name of the native function and then this name here, and you think these things have to be the same, maybe, but they don't. So create vector is the name of the function in Lua, and I've bound it to this native function called vec create vector 2D. So that's all I need to do to bind the native function. Let's just see if we get any different errors. I've got an unreferenced parameter up here, so because I haven't written that function yet. Let's just get rid of that while we're testing. So attempt to index a function value global v1. So it's saying, what line was that on? On line 4. 1, 2, 3, 4. I think it was that one. Was it this one or that one? But either way, I think it's trying to access these values, and it's trying to access v1, and it doesn't exist yet because I didn't return it. So that makes sense that I haven't written this function yet, but we're getting a bit further through the Lua script. So what I want to do in here is just my vector is going to be a table. So I'm going to do my vector as a table, and we didn't do this last time, but I can make a new table just by doing that. So this isn't a meta table yet. This is just a table. I need to get my L back. This is just a normal table that I'm going to return from the function. And one of the things that I want to do with it is I want to just push in a couple of default values. So my new table is there on the stack. I've pushed that onto the stack. So let's just push. This will be like a C++ constructor. This is the equivalent of it. I want to push a couple of values on that are like my defaults. So this vector is going to be a 2D vector, so it's going to have an x value, and I'm going to set that to 0 as like a default. So remember, the table's on the stack there. That's the key that I'm pushing into the table. That's the value I'm pushing onto the key. So I do Lua set table, and it wants the index to the table, which is -1, -2, -3. So all I'm doing is I've made a table, and I'm initializing a value of x to 0. And keep in mind, this set table function pops the key and the value off the stack, and it leaves the table there. So I can do that again. Remember, the table's still on the stack. I can do a y value, push in 0 again, and set the table. And again, it pops the value, the key and the value off the stack. So we're just left with the table that we created. And then we're going to say return 1, which is that exact table that we did. So at the moment, that's all we need for that. So that's just going to make our create vector 2D work, which is we're going to do as a table in this case, just to prove a point that we can do that as a table. So maybe we'll get a bit further in here now. We're going to create vector. Hopefully that returns the table. We're going to create another one. We're going to set the x value on each one differently than what it was constructed at as 0. And then we're going to try and add them together. So that's the bit that's going to be a little bit weird. So let's see how far we get now. Attempt to perform an arithmetic operation on a table value global v1. So it's telling us that we're attempting to add these two tables together, and that's not really something that Lua understands. It's like, you can't add these two tables together. That doesn't make any sense. Except if we get metatables involved in this, this is something we can do. So what we can do is we can assign a metatable to the vector table that we created. So that v1 and v2. Tables can all share the same metatable. So we only need to create one metatable and all our vectors can share that same metatable. So we'll do that once we give it a metatable. Then we can add on the meta methods, and then we can define our arithmetic operation that's missing, and we can get these tables to add together. So first thing we'll do is we've pushed down on our function there to create it's like our constructor. We're going to use a new function called Lua new metatable. There it is. So this is going to create one of the metatables. Well, the metatable that we're going to need. It wants a name. It's a bit weird. Metatables, when you're using this, they kind of are global, but they're not globals. They're stored somewhere else, and that's something that we haven't covered yet. But for now, you don't need to know where they're stored, other than you just know that this makes one and puts it somewhere for us, and it wants a name for it. So we'll just call it vector metatable. Yeah, vector metatable. So we only need one of these, and all the vectors are going to share that, and that's just sitting there on the stack right now. So at this point, we should probably go back up to our create table function here, and what we want to do in here now is assign that metatable to the table that we're creating in here. So we only need this one, it stays here forever, and what we can do is assign that one in here. So after I've created my table, I've pushed on my X and Y. What I can do now is Lua L, I can get metatable. So remember, we've previously created this metatable, and here it is, it's called vector metatable. So now every time we create one of these, we're gonna pull this vector metatable and put it onto the stack, and then we're gonna do, maybe not surprisingly, set metatable. And this wants Lua state, and it wants an index of the object it wants to set it on, I believe. Is that right? So it wants, at the moment, this is just going to be -2. It's -2 because we've pushed our metatable on the top of the stack, and there's our table that we're setting the metatable to. So it wants the index of the thing it's going to set the metatable to, and it's expecting this metatable to be at the top of the stack, and it'll pop that off when it sets it, and then at the end that still just leaves our table on the stack, which is what we wanted. So we've created our vector2d, we've assigned it a metatable, which we created a bit earlier down here. We only have to do this once, this new metatable. Let's just see if that still works. It probably should, but nothing's changed. We're still attempting to perform an arithmetic operation on vector metatable, though. That's changed. So you can kind of see that something's happened there. That it's saying we're not doing it on the table anymore. It's saying we're doing it on the metatable. So it's trying to do it. It's trying to do that add for us, but it can't seem to do it. So what we should do now is we're going to put a meta method onto the metatable. If that isn't crazy enough, then what is? So Lua defines a bunch. I can't remember how many there are, but there's quite a few like meta methods, especially named methods that you can define on a metatable, and they will do stuff for you. And one of them you can define is the arithmetic operation. So you can define what happens when Lua sees that v1 plus 2. You can define the thing that's going to happen in this metatable when that happens. So you push on the name of the meta method that you want. What I'm going to do is I'm going to put this meta method into this metatable. I'm saying meta a lot in this tutorial, so hopefully that's not really annoying. And these are specially named, so you'd have to look these up in the Lua reference manual. But for the arithmetic operation, it's going to be add in this case, and then we have to push on. So that's the key. That it's going to be metatable dot kind of underscore add, and then we have to push on what do we want it to do when the add happens. So really what we want is we want another function. So I'm going to push on another C function. So this is the thing that's going to happen when the arithmetic operation happens, and I haven't written a function for this yet, so I'll just call it underscore underscore add, which is kind of makes sense because I mean that's what it's going to do. It's complaining there because I haven't done it, and then I need to set table on that. Which remember, set table doesn't set the table; it sets a field in the table, and it wants the index of the table to set, which is -3. And already you can see the advantage of the fact that Lua's reusing tables to do something new, because you've already learned how to use set table. So now when you're doing metatables, it's like this procedure here is the same thing you did on normal tables, because essentially metatable is a normal table. So so we're defining the add function, but we just haven't created one or written it yet. So let's do that. Let's go up here. Let's create a new, let's create our add function. It needs the Lua state. It's the native function. Lua state. And again, it wants to know how many values am I going to leave on the stack. In a moment, I'm just going to say 0. Let's just take that out for now and see if it still compiles. So it still compiles, and well, nothing's happened now. So we've not got any errors anymore. So maybe we fixed it, but maybe we haven't. And I'm going to go out and say that, well, we haven't written this method yet, but it's quite possible that's being called. In fact, we could check that. Let's just see that add was called. Let's just see if we saw that. So there you go, add was called down there at the bottom. So we've successfully invoked our meta method now on this table. When we did this add operation, that method was invoked. And again, this is something you're going to have to look up in the manual every time you do one of these, but you have to look up for each one of these meta methods, like what is it going to provide to you when it gets called. And this one in this case provides it's going to push on 2 parameters. There'll be 2 parameters on the stack, and they will be, I think the first one will be the table on the left, and the next one the table on the right. So I'm going to get v1 and then v2. So I should be able to see Lua is table. I should be able to see -2. That should be the left table, and -1 should be the right table. And in this example case, the left table is v1 and that is v2. So let's just see. Oh, need my Lua state back. Let's just see if that runs. So add was called and it didn't assert. So we've got 2 tables on the stack. So now all we need to do is perform our add operation on these 2 vector tables. So again, really this is just stuff we've learnt before, because we're just using tables like we did before. So we need to get the value of x. Push string. So we need want to push the. We've already got the table on the stack, so we're going to push the key on the stack that we want to access, and then we're going to use. Remember, we did this last time. We're going to use Lua get table to get that value back on the stack. So -1 is the key, and -2 is the left table, and -3. Sorry, -2 is the right table, and -3 is the left table. So let's go for the left table first. So that gets the value out of the table, and that should be a number. I'm not going to check it properly, but that's x left. So this is just going to be a lot of typing now, but this isn't the most hopefully if it works, it isn't the most complicated thing in the world. So I've pulled out the X value for the left table, but keep in mind that that was on the stack. So what I'm going to do, because I'm going to do some more operations after this, is I'll just pop that off the stack. Again, we've not used pop before, but it literally pops the top of the stack, which is the last thing you pushed on, and you just say how many things you want to pop off the top of the stack. So I'll just pop the number that I just pushed on with that get table. And then we want to do the same thing again, really. So let's just start again, but we want to get the other table. So we want to get the X value again. This time it's -2 because we've got -1 is the key, which is X, and -2 is the right table. So that should be X right. We'll get that on, and then we'll pop that value off the stack as well. And then we've got our left and right. We can add these two together. Lua number, we want X. So we want the value of the X as X is added together. So X left plus X right. So that's our result of the X. I probably won't do the Y in this example, but the Y would be exactly the same, except you've got a Y value there. So I'm adding the X together, and now what I need to do is, well, shall we just get to that point? Let's just print out to see if we, let's just print out to see what we got for this X added. So let's just see if we can get to that point in the program. So X added is 52. So let's just have a look at our Lua script. So there's our 10, and there's 42. That is 52. Let's try 11 and 42. So there you go. So we have actually managed to get it to call a function that allows me to add the values in those tables together. Except at the moment, what I really want to do is add them together, put them in a new table, and then return that. So this is one of the reasons why I turned these things into just static normal functions before, because now what I can do is I can just call my create vector 2D function directly. I mean, normally these would be called by Lua, but I can just call it myself. Because what this does is creates my table, constructs all my values, and sets the meta table, and then it puts it onto the stack, and it leaves it on the stack for me. So this appears to be exactly what I want. I want to create this table, and I want to return it on the stack. So I'm returning one value. So the only thing I'd really want to do is, keeping in mind that now I have my just a new vector table on the stack, I want to push my added X value into it. So again, this is pretty much the same thing we've done before. We're going to push a string on, which is going to be the key. So we want the key X. And we're going to push a number on. That's going to be the value that we're going to set in the table. And this is going to be our X added value that we calculated. And now we're going to do one thing that we've probably might be a little bit surprising here, because we've not used this before, and we're going to do something called Lua RawSet. And this is equivalent to set table, but with a slight difference. So these get tables and set tables that we've been doing, where it's not setting the table, it's setting a value in the table. This is the equivalent of set table. So I'm going to set the table that I created there. I'm going to set the X added. So it's -3, -1, -2, -3. It's the equivalent of set table with the exception that it will not invoke the meta methods, and that's quite important sometimes, because you can get yourself into a loop. Like you're inside the meta method, you try and set a value and it sets the meta method, then you set a value and it sets the meta method. So in this case, I definitely just want to raw set this value. I don't want it to invoke any meta methods at all, because I'm already invoking a meta method. So I don't want this thing to go into like some recursive loop. So RawSet is the equivalent of set table except it doesn't invoke Metamethods. So that's quite an important one there. But essentially what I've done there is created a new table and I've added the X value. Again, you need to go through and add the Y value as well, but I'm not going to do that in this example because you get the idea. It's just rinse and repeat for that. So let's have a look. So it builds, does it run? So X added is still 53. But let's just in this script, let's just see what the result of v3x is, and then so this is just now just so I haven't actually put any of the Lua libraries into Lua, so the print won't work in here, but I'm going to set that into a global. I'm going to create a global called result. I'm going to set it to v3x. Remember, that's that table we created. I mean, that should still work. Again, it won't print out anything different, but it shouldn't do anything wrong, which it didn't. And then down here, we'll just after this is all finished, down here, we'll do Lua get global, and we'll get the global result. And then we'll just so that's pushed it onto the stack, and then we need to do Lua to number, I think it is. Yeah, it's a number, this. So the last thing on the stack is my number. So Lua number, and that's the result. And let's just print the result out. So this is just pulling the value. Well, in the script, I've pulled the value out of the v3 table that I created, the X value, and I've just pushed it into a global there. I could have done it a different way, but I'm just showing that down here now I can get that global and look at the number. And this should be the same number that I calculated before, except I've got to cast that to an int. So let's see. So result was 53. Let's just put the formatting on that. So there we go. So we successfully we created a new table. We added a meta table, and then we added a meta method to that meta table, and we used it to define the add operation of what happens when these two tables are added together. And in this case, it added the two tables and created a new copy for us. And then we just did a little bit of extra to print out that result. So that's just one of the meta methods, and there's loads more, and they're all really useful. Well, I say they're all really useful. Like, there's a few that are very, very useful. So next time we'll probably go back to the user data that we did, and we can refactor that with the new knowledge that we've got about metatables, because these metatables, in this example, I wanted to show you that you can push these onto a table, but you can also push them onto user data as well. So once they're on the user data, we can use that to do things that we couldn't do before and solve problems that we maybe didn't know we had. So we'll probably look at that next time.